Okay, so hello and welcome to Non-IITN. If you enjoy the content, please don't forget to like, share, and subscribe to our channel. So, in this question, what we are given is the following. So, this is a question from TIFR GS 2024. Okay, and the question is as follows. Let f be a function from the positive reals, non-negative reals, a continuous function, and the hypothesis given is if limit n tends to infinity of the integral 0 to 1 f of x plus n dx is equals to 2, then what can be said about the limit limit n tends to infinity integral 0 to 1 f of nx dx. Okay, so we are being asked about what can be said about the limit. So our argument should be whether the limit exists or not, and if exists, what should be its value. Okay, so let us try and analyze. Okay, so the proof strategy. Okay, now the strategy would be very simple. We want to analyze the given integral limit n tends to infinity 0 to 1 f of x plus n dx, which is equals to 2. This is exactly the problem which we are going to analyze. Okay, fine. And then we would like to relate. So obviously there is some reason why this hypothesis is given to us. Relate it to the integral 0 to 1 f of nx dx and evaluate as n tends to infinity. So this should be the simple proof strategy. Okay, so the first thing is we would like to simplify the integral provided as hypothesis. So we are given limit n tends to infinity integral 0 to 1 f of x plus n dx. Okay, we want to simplify this. How do simplify this? So let x plus n is equals to, let's say, y. Then, so this is the simple method of substitution. Then I have dx is equals to dy, and as x equals to 0, y is equals to n, and x equals to 1, y is equals to n plus 1. Very simple, right? So therefore I have limit. Now clearly, as what do I have here? So limit n tends to infinity integral. Now I have the integral from n to n plus 1 f of y dy, and we know that the value of this limit is 2. Okay, so this is what we are gonna use. Okay, please keep this in mind. So let me just write it as star. Okay, now we simplify the target integral. So what is the target integral? The target integral is integral 0 to 1 f of nx dx. Okay, so we want to simplify this, and what we will be doing, we will be again using the method of substitution. Okay, so let nx be equal to y. What does that mean? That means that n dx is equals to dy, and as x equals to 0, y is equals to 0, and x equals to 1, then y is equals to n. So this integral becomes, therefore we have the integral from 0 to n f of y dy and a 1 upon n epsilon, right? Pretty easy. But now actually we are done. Why? Observe that I can write it as 1 upon n integral 0 to 1 f of y dy. Okay, so let me write it in third brackets, plus the integral 1 to 2 f of y dy, plus so on and so forth. We have integral, say, n minus 1 to n f of y dy. Now I guess we are done. Okay, so let me take this to be double star and continue in the next slide. So what do I have in double star? So double star implies we have limit n tends to infinity integral 0 to 1 f of nx dx equals to, so let me write it in this way, integral 0 to 1 f of, okay, so let me just give a slight change of variables, so f of x dx plus integral 1 to 2 f of x dx, and this continues till I have integral n minus 1 to n f of x dx, and this divided by n. Now observe that if we let xn to be the integral n minus 1 to n f of x dx, then we know, then by star, what do I have? By star, limit n tends to infinity, xn is equals to 2, right? But then we have a very important theorem on limits, which is called the Cauchy first theorem on limits, which says in some sense the following, that is, if limit xn is equal to L, then limit n tends to infinity, x1 plus x2, so on and so forth, till xn upon n, which in some sense is arithmetic mean, is also equals to L. And observe that this yields an answer. Therefore, limit n tends to infinity, integral 0 to 1 f of nx dx should be exactly equal to limit, which is actually equal to limit n tends to infinity, x1 till xn upon n, by how we have defined xn here. So let me just slightly change this. I don't want to confuse my notation with this, right? But then that should be exactly equal to limit n tends to infinity xn, and that is exactly equal to 2. So this limit is exactly equal to 2. So the conclusion, the final answer is this limit is exactly equal to 2. Okay, so thank you for watching, guys. Please like, share and subscribe to Non-IITian if you like this video. Meet you guys soon.